Welcome to Code You Can Use. In this screencast, we'll go through the implementation and testing of the Reactive REST API using Spring's Webflux and the programming language Kotlin. This turned out to be much longer than I expected, so we have broken it up into multiple parts, and this is part 1. Let's create the project in our IDE. We'll use Java 11 with the Spring initializer, and we'll call it Webflux demo. Change the language to Kotlin and use Java 11 as the JDK version. We'll use the latest release, which is Spring Boot, which is 2.2.7, and we'll add in the starter for the Spring Reactive Web. Now that the project is created, we start by creating a test class. The name of this test class should tell us what we are testing. So in this case, we'll call it Webflux Demo API Test. We'll annotate the class with Webflux Test. Webflux Test is a Spring testing framework's annotation, and it provides us a way to isolate the application context to only those components that we need for the Webflux test. In this case, the controller and the REST controllers. Webflux test also allows us to auto wire the web test client, which we are going to do in the as a constructor parameter. And now that we have that, let's write our first test function. We are going to do a get, so we'll just call this a get test. So we have the client.get and a URL. Let's keep it simple now. We'll call it we'll call an endpoint /demo. Dot as change tells the client to make the call, and we'll expect the status to be okay, and let's test it. This is sufficient to get us started, and of course it fails because we have not implemented the endpoint yet. So let's call this class for handling this API, the Webflux demo API handler. Okay, and we've created that. We'll annotate it using the REST controller annotation. This allows us to do both the annotation style as well as the functional style, the Webflux programming. So we are going to set up the two sections here to demonstrate both styles. So let's start with the annotation style. We'll do a get mapping /demo. This means that this function will be called when a get is made to this /demo endpoint. Okay, and that should do it. We don't need very much to be providing this endpoint with an OK status. Let's comment that out and move on to the functional style. First thing we need is a way to route the request. So we'll set up a function routes. We inject the handler into this function. The reason for doing that will be apparent later on. We'll specify that if we get a get on /demo, we want to be performing a certain function. So in this case, this function would take a request, in fact a server request, and you return a server response with the OK status. So server response dot OK and a body. In this case, we don't have a body yet, and we'll just use a mono.empty to as the body for now. Okay, Let's run the test again. And we see that the test is failing, and I've not put in the bin annotation to this routes. So let's do that and run it again. And that passes. We don't want to be writing all the handler functions within the routes. So let's try to extract this, move it into a separate function. So let's see, let's convert this into a function that we can extract first. And then we'll convert this into a functional get method. Okay, that looks a bit complicated. Let's simplify it a little. The method is now done. Let's make sure we are using it the right way in the route. That seems okay. Let's run the test again. And it feels okay because we have a syntax error. Let's remove that and reformat and run it again. And it passes. Now that we have both the annotation style as well as the functional style, what happens if we have both handling the same endpoint? So in this case, the get/demo, does it still work? We can actually put both of this into the same handler or controller. But which one gets caught? So let's put some print statements. We'll put a print line annotation style into the annotation styles the handler, and a functional style print line into the functional get method. So when we run this, let's take a look. We find that the functional style takes precedence over the annotation style. Let's remove the route bin so that we can focus on the annotation style for the next step. We can test this by rerunning the test, and we can see from the test result that is the annotation style that is being called when the bin is removed. Let's go back to the test and add more verification to the test. In this case, maybe we would like the body to be empty for this particular call. So we can say expect body is empty. And when we test this, it still passes because of course we have not returned anything from the handlers yet. So we have tested the annotation style. Let's now uncomment the bin so that we can test the functional style. And running the test, that passes too. Now we go back to the test. Maybe instead of expecting the body to be empty, we expect it to contain some JSON string. So we can use the .json method, and this accepts a string, a JSON string. So in this case, maybe we expect something with the element ID of 100. Okay, so that's what we specify in the test. Let's again work on the annotation style of this handler first. So we uncomment the annotation style and comment the route bin. And for this handler to work, we needed to return a mono of the JSON string. So we'll use the mono.just and then the string. And we need this function to return the correct type, which is mono of string. Now let's run the test again and see whether this works. And it does. Okay, let's move on to the functional style programming by commenting this out and uncommenting the route bin. Let's copy and paste this the JSON string. So instead of returning an empty mono, we will now return a mono with just one data element, which is this JSON string. And let's test that. And that works as well. Suppose we have more elements in the JSON, and we can add this to the test by adding to the JSON string. So maybe we are also expecting a name element that's of the value test. So we'll put that in, and in the same way, we'll modify the handler functions to return the same JSON string. So let's test that. So okay, this fails. Let's take a look and see what's happening. Okay, it seems I have made a typo while typing this. Let's correct that and rerun the test, and it now passes. It's not ideal for us to return the JSON string like that with every test, and most of the time we really don't we don't have a JSON string. We might have some kind of data structure and so on. And one way we can represent this is to use a hash map. In this case, it's a hash map of string and any, and we would maybe call this result. And the result, within the result, we can have, say, in this case, ID, which is 100, as well as name, which is set to test. And instead of typing out the JSON string, let's see whether we can use this hash map as we can just return this hash map. So that works. Okay, we'll move on to try this out in the annotation style. So uncommenting the annotation style, adding this hash map initialization. Now we have to change the return type of the annotation method to a hash map of string and any. And let's run the test, and it should pass. Okay, great. Using the string literal for testing of the JSON is not just very cumbersome in the handler; it's also very cumbersome in the test. So we are going to use another function called JSON path, and we would add this to the dot aspect body call. Okay, so we can say that we expect an element at the JSON path of ID to be equal to 100, and the element at the JSON path of name to be equal to test. Okay, let's remove the JSON test and run this. And this achieves the same test as the JSON method. Now let's go back and make sure that it works with the functional style. And we run the test, and that works too. So using hash map for the result is a quick and easy way, but it lacks type safety and null safety. So we are going to replace this with a DTO. So in this case, let's call it a response DTO that has two elements, which we would initialize with 100 and test. And let's create this DTO. We are just created in the same file so that it's easier for us to see what we are doing. So the first element is ID, the second element is name. We will make this a data class, and we'll have we'll use a val for this properties. Okay, so removing that, and let's test this, see whether it works. And yeah, it's working. So let's move on to the annotation style, commenting out the routes bin and uncommenting the annotation style handler. And again, we need to make sure that we have the right return type for the handler. And okay, let's test it. And that works too. Now that we have this DTO, we can also use the DTO in the test. So we can say that instead of expecting a body that we don't know, what format it comes in, we can say that we expect a body that conforms to this response DTO, and we would use we can use a few different methods to verify this. The first will be is equal to, so we can say that the return DTO is equal to DTO of ID 100 and name test. Let's run that, and it passes. Okay, we'll do the same with the functional style. So I'm commenting the routes bin and running the test, and it passes also. If we want more fine-grained control on the testing, instead of using is equal to, we can use another method called consume with. Consume with takes a method, and within the method we can say we can use assert that from assert j or any of the assertion libraries, and we can say that assert that it, which is the entity exchange result of the response DTO. Okay, so it dot response body is equal to response DTO 100 and test. So this is equivalent to the previous is equal to test, and that passes. But we can do a bit more than this. For example, if let's say we have some other fields that's within this DTO that we might want to ignore. For example, we might have a new field called created at, which is the creation time of of the object. So created at will be of the type instant, and the default will be instant.now. And when we rerun the test, we find that it now fails. Okay, and the cause of the failure is that the created at times are of course different, because these are two objects that are created at different times. So we can say that let's ignore this created at field, and that passes. Okay, we can specify this field as a string, or if you want to be more type safe, you want to make sure that at compile time you are checking this name of the field. You can use something like the dot name on the k property. Okay, and you might want to have another test to make sure that this created at is actually something that's valid. Since we don't know the exact, we don't have the exact created time, we can't use equal, but we can say that this is something that might be before now, right? So that the DTO or the return object is created before it is sent for the testing. Okay, so that passes, and if we try this with the annotation style, we see that it passes as well. Using consume with also allows us to access the response headers. So for example, we might want to see whether there's something in the response headers. So we can assert that it dot response header is empty. Let's run that and see what happens. So it's actually not empty. We can see that there's the content length and the content type that's returned by Spring's Webflux automatically. Maybe we are interested in not just that the response header is empty, but we want to make sure that it's returning certain data. So we might have location response header, and running the test. We see that this actually gives us a null if we don't specify anything in the handlers. So if we change the test to is null or empty, and rerun the test, it passes. So that was using the annotation style. Let's make sure that it behaves the same way under the functional style. And the test passes, so it's the same. If we want to return something in the header, in this location header, we can use the header method. Okay, and If we add this, of course, the test that's expecting it to be still null or empty will fail. So going back to this this test, we can say that it contains the return result. So if the return result is my location, it should. So when we run this test, it should pass. Okay, we have done it for the functional style. Let's go through how we do this. We return the same location header in the annotation style. Since we don't have a explicit response object in the annotation style, we need to add that in as a parameter to the handler method. So in this case, we'll call this, it should be a server HTTP response. Okay, we'll use the one from the Reactive Webflux. And yeah, and we'll call this the response object. And within the handler, we can call up the headers and set the location header to a certain value. So in this case, we'll set it to my location, and let's run the test. And you can see that that works as well. There are a few other ways to access this this headers. For example, using the entity response object or the server response object. But in those cases, the function becomes the annotation style becomes very much like the functional style. So it might be more better at those points to just use the functional style instead of the annotation style. We've gone through a few ways that we can test the data that's returned in the response. Let's go back to the test case and go through a few different methods we can be sending data in our request. We'll go through the two commonly used ones. The first will be as a path variable. So in this case, we might say that instead of the endpoint being /demo is /demo/ there's an ID or a name that's passed in as a path variable. Okay, so in the annotation style, this is quite straightforward. We can just use the path variable annotation. The variable name can be the same as specified in the path variable in the endpoint. In this case, maybe let's change this path variable to be for name instead of ID. So we can change the endpoint mapping to curly bracket name, and then we can use this. We can use this path variable as part of the returned result. If we run the test right now, we can see that it will fail because the test is still expecting a different name element in the returned result. So let's change that. We might say that this is since we are passing in my ID as the name. So we'll change the test to test for that. And okay, something is still not quite right. Let's take a look. Okay, we removed the location header, but we are still testing for it. So let's go ahead and remove the test. Now let's run the test. And we see that it passes. Okay, let's go back to the handler functions, and let's do this for the functional style. In the functional style, instead of using the path variable annotation, we will extract this path variable directly from the request. So we can say that this request dot path variable, and give it a name. So in this case, is a path variable called name. We need to make sure that the endpoint we specify in the route recognizes this. And let's store this in a local variable. And use it in the result. Okay, that should do it. Let's rerun the test. Oh yeah, let's remove the location header and rerun the test, and it passes. So going back to the test, a better way of embedding the path variable into the URI is by using hash map. So let's set that up. We can change the variable name to, okay, so we are using the same syntax in the URI path as what we have used in the endpoint. And we'll inject this. There are a few different ways to do this. One is we'll pass in a hash map as the second parameter to the URI method. So let's run the test right now to see whether this works. And it does. Okay. So we can in fact change the name to be, some random string that we bang out on our keyboard, and it still passes. Okay, so now let's make sure that this works in the annotation style. So uncommenting that, we now run the test again, and it passes. So path variable is a very common way for us to be sending data from the requester to the handler. The other common method for us to do this is through the query request parameters. For the annotation style handler, we can pick this up from the request by using the request param annotation. So let's set up a param that might be just called param. So this could be a string. from the client, we need a way to inject this query param into the URI. Okay, and the way we do it is a bit more involved. We need to, one way to do it, probably the simplest way, is to use another form of the URI method where we are injecting a builder. So this will specify a function that takes the builder and ultimately builds the URI. Okay, and we can say that it builds it with the path variables, and the path is slash demo slash open curly bracket name. Okay, and in between this, we can specify the query params. Now going back to the handler to make sure that we have indeed received this parameter. So let's just print it out. And when we run the test, we see that the test fails. Let's take a look at the output of the test. Okay, we can see at the top that the param is passed in properly, but we have made a typo in the URI, the path that we have used in the test. So let's go back and fix it by adding the closing curly bracket and rerunning the test. It now passes. Now let's go back to the handlers, and we will now do the functional style by uncommenting the routes bin and commenting the annotation style handler. So as with the path variable, we'll make a explicit call to the request to extract this query param. So we'll put it again in a local variable. And let's also print this out. And when we run the test, okay, it passes, and let's take a look at the output. Okay, we can see that this is passed in as an optional. Okay, so it's optional this param. Here we come to end of part 1 of this screencast. There are a few other topics we want to cover. For example, doing a post and using a request body to send in more data to the request. So stay tuned for part 2. In the meantime, if you like this, please like and subscribe to this channel. Thank you.